By Newton's time, the clockmakers were using pendulum to keep precise time. The swings of a pendulum are so regular that the clocks can be as accurate as a few seconds per week or even per month, on land. The major errors come from two sources: the variance of temperature and the lubricant oil. The frequency of a pendulum, that is, how fast it swings, varies with its length. Just imagine the swings in a playground. The longer the swing, the slower it swings. So when temperature increases, the length increases due to expansion, and the pendulum slows down. When temperature decreases, the length decreases due to contraction, and the pendulum speeds up. The changes are very small, but enough to cause error of several seconds. The solution to this problem was the gridiron pendulum, invented by John Harrison, who later made a watch that was accurate to 3 seconds per day at sea. The gridiron pendulum uses two types of metal rods, typically brass and steel, to compensate the temperature variance so that the pendulum length keeps the same and the swings keep regular. The other error source was the lubricant. By 1720, the most popular was goose grease. However, the grease would congeal in winter and thin out in summer. It would turn rancid and corrosive. It would attract dust and dry out, leaving abrasive mixture behind that damaged the mechanic parts. Nowadays, we have either conventional oil or even synthetic oil that outperform the grease in every aspect. In fact, some WD-40 would serve the clocks better than the grease. Unfortunately, none of these advanced chemicals was available in the 18th century. Again, John Harrison found a brilliant solution. When he built the tower clock for Brocklesby Park at 1722, he used lignum white, a dense, heavy tropical hardwood that gives grease itself when irritated, to make the bearings of the clock. The clock is still working after hundreds of years. However brilliantly designed and fabricated, a pendulum clock is susceptible to motion. The motions will disturb the regularity of the pendulum, and thus the timekeeping. To solve this problem, the pendulum needs to be replaced by something less sensitive to the motion. Interestingly, the item can be found in a playground as well, the seesaw. If the seesaw is balanced with springs, it will oscillate regularly. When you agitate the seesaw, the energy will be balanced through both sides. Thus, the oscillating amplitude may change, but the oscillating frequency remains the same. For such a device, the larger the oscillating amplitude, the higher its tolerance to interruptions, such as motion. The problem is that the seesaw must be huge to have large oscillating amplitude. Luckily, Another playground item provides the solution. A spinning wheel balanced with springs can oscillate many circles one way and then backward. In clockmaking, this part is called a balanced wheel. Again, it was John Harrison who incorporated this part in his ocean chronometers.